Loudness in decibels is related to the intensity of the sound by the equation, and this is the equation given, where IO is equal to 10 to the power of negative 12 watts per square metre. This value is the lowest intensity of sound that can be heard by human ears. An ordinary conversation has a decibel of 60. Calculate the intensity in W/meters squared. If the intensity is doubled, what is the change in loudness corrected 2 decimal places? Again, first thing I'm going to do is I'm going to pull out the important information, but opposed to writing it all out again, I'm just going to highlight what each of my variables means. So loudness is L, intensity is I, the initial intensity is this. Okay, so an ordinary conversation has a loudness of 60 decibels. So a loudness of 60, calculate the intensity. Now for A, I'm going to start noting down the things that I can see in my question. So here I've got L, I've got I, I've got IO. Now we're saying that the loudness is 60 decibels. We want to calculate the intensity of it, so we don't know this one, but we are given in the question that IO is equal to 10 to the power of negative 12. So I've pulled out all of the variables and I've assigned them. Now I can substitute it back into our equation using FSA. So there's my formula. Now I can substitute back into it. And now I can start rearranging so that I can get I on its own. This is the variable that we're trying to solve for. So first thing I'm going to do is I'm going to take this 10 to the other side. Currently it's multiplying, so I'm going to divide by 10. 60 divided by 10 is going to leave me with 6. So this is what's remaining on the other side. Next thing I'm going to move across is our log. Now whatever the base is here is what's going to be the base over here, and it'll be to the power of that. So it'll be 10 to the power of 6 is now equal to I over 10 to the power of negative 12. Okay, so next thing that I want to do is currently this is dividing. So I want to take this across by multiplying the other side by 10 to the power of negative 12, which will give me 10 to the power of 6 times 10 to the power of negative 12 is equal to I. Now, as you can see here, we've got two things with the same base, multiplying, meaning that we can add the powers. So 6 plus negative 12 is going to give me negative 6. So I will be equal to 10 to the power of negative 6. Now, it's important to put the unit back on the end. So that'll be watts per metre squared. Okay, and that's how we've answered the first question. The second question, B, if the intensity is doubled, what is the change in loudness correct to 2 decimal places? So decimal places. Now, I'm going to solve this a different way to how they solved it in the textbook, but I will get the same answer as them. It's the same thing, it's just doing it a different way. So if I am going to double the intensity, that means that I'm going to start by stating my variables again so that I can substitute into my formula. IO won't change. That's one that's set in the question. He is just stock standard. So we want to know what happens to the loudness when I double the intensity. So over here we worked out that the intensity was 10 to the power of negative 6. So if I times that by 2, what happens to our other variables? So L is equal to, now I'm not going to state the formula again, just because I think I'm going to run out of space. 10 log 10 bracket 2 times 10 to the power of negative 6 all over 10 to the power of negative 12. Now here you can see I've got this divided by that. So really I'm saying 10 to the power of negative 6 divided by 10 to the power of negative 12. When they are dividing, it means these things minus. So really I'm going to do 10 to the power of negative 6 plus the 12. So that's going to give me 10 log 10 bracket 2 times 10 to the power of positive 6, because these will turn into a positive, meaning that when I add them together, that's what's going to happen. So now I've got it in this form. Next thing I need to do is chuck this in my calculator. Now, because this has a base of 10, that means that I can, let me just find my calculator, desktop, there you are. Because it has a base of 10, I can use my standard log button. So 10 log bracket 2 times 10 to the power of 6 bracket equals 63.01. So the loudness, when I've doubled the intensity, becomes 63.01 watts per meters squared. So if the intensity is doubled, what is the change in loudness? So I found that when I doubled the intensity, this is the loudness, but the change in loudness is going to be this one minus the loudness in that one. So 63.01 minus 60 will give me 3.01 watts per meter squared. So the change in intensity, the change in loudness when I double the intensity is 3.01 watts per meter squared. Now, the other thing that I could have done, that's it. That's all we're going to talk about.